Now see, it's written a fluid which is incompressible is called an ideal fluid. So what is a fluid? Fluid is basically substances that can flow. And it not only consists of only liquids. Fluids comprises of liquids as well as gases. Now then comes the topic, pressure of the liquid. See, the perpendicular force applied to the surface is known as thrust. For example, this is the container and I have kept a liquid. Now the molecules will collide with this wall of the container. So the perpendicular force that will be exhibiting on the walls of the container, that perpendicular force, 90 degree, this force is known as thrust. It's the force perpendicular to the surface. And fluids at rest exert force on the walls of the container. So this perpendicular force is known as thrust. Now see, the total perpendicular force or thrust, this pressure, this force thrust, exerted by the liquid at rest on a unit area surface. Means if I take a unit area, 1 meter square area, and I consider all the force acting on this 1 meter square, then that quantity would give me pressure exerted by the pressure exerted. Fine. So pressure would be equal to force perpendicular force. What is the perpendicular force over here? Thrust. So perpendicular force or thrust per unit area. That quantity is known as pressure. So what according to you should be the SI unit of thrust?
Newton per meter square.
For thrust? Thrust is basically force. So what should be its SI unit?
Newton.
Only Newton. And what should be the SI unit of pressure?
Newton per meter square.
Newton per meter square. And do you remember we have seen this unit same previously in the last chapter in stress? Force per unit area was stress as well, right? So what is 1 Newton per meter square equal to?
1 Pascal.
1 Pascal. So you can say Newton per meter square or Pascals. And the CGS unit for this is dyne per centimeter square. So the dyne is the CGS unit of force and centimeter is the CGS unit of length, meter. So that is dyne per centimeter square. And see, since pressure is inversely proportional to area, we have some practical applications of pressure, like nails and pins have pointed ends because it decreases the area and increases the pressure because of the pointed end. Similarly, wide wooden or concrete sleepers are placed below the railway tracks. Buildings have wide foundations. Why buildings have wide foundations? Because that increases the area, which decreases the pressure. And it is painful to walk on road covered with pebbles having sharp edges because the area is less and the pressure put on our toes or the feet is very high. Fine, just note this down, then we move further.
Done, ma'am.
Now see, the next topic is atmospheric pressure. For knowing atmospheric pressure, I hope you know what is atmosphere. Like if this is the earth, the gaseous envelope around the earth is known as the atmosphere. The layers of the atmosphere also exert pressure. So that pressure is known as atmospheric pressure. Fine. See, the density of air decreases as we go up from the surface of the earth. So therefore, atmospheric pressure is maximum on the surface of earth and goes on decreasing as we go up from the earth. Since the density of air is not constant, we are not able to calculate the atmospheric pressure accurately. We use it by a device known as barometer. But the value of atmospheric pressure measured on earth, let be represented by P naught or PATM also you can say, is 1.013 into 10 to the power 5 pascals. And you have to remember this value because most of the time it won't be mentioned in the questions. All right, is this clear?
Yes, ma'am.
See, now I want to ask you, here I was telling you that these molecules exert this perpendicular force. Can you guess why do they exhibit this? Why fluids at rest exert force or that thrust on the walls of container? Any guess?
Because they keep moving randomly.
Yes, yes. They keep moving. See what happens. This is the container. And this is the fluid. Any liquid is kept. What happens at a temperature more than 0 Kelvin? These molecules have kinetic energy or thermal energy. So they collide with themselves as well as they collide with the walls of the container. So, so this exerts kinetic energy. So I will write it down for you. All molecules at temperature greater than how much?
0 Kelvin.
0 Kelvin, yes. Greater than 0 Kelvin have thermal energy, or basically this thermal energy is the kinetic energy. And due to this kinetic energy, they collide with the walls of container. Just note this down also, this much.
Done.
Done?
ma'am.
Done? See, now we have discussed that this liquid column exerts pressure. Now let us calculate what is this pressure exactly. How much is the value of this pressure? Now we'll be calculating the pressure exerted by a liquid column. So let's say I've taken this cylindrical vessel and I've I've filled it with a liquid. Now see the height of the liquid column. Noted that this is not the height of the cylinder, the height of the water column. Let it be h. I've taken it as h. And A is the cross section area of the cylinder. And rho is the density of this liquid field. Fine. So see, the force that would be exerted would be equal to its weight, mg. What is the formula for pressure? If F is the force exhibited and A is the area. Can you tell me what is the formula for pressure?
F by
F by A. And force is equal to the weight. So can I replace F by mg, mg by A? Is it fine?
yes. ma'am.
Now see, density is equal to mass by volume. So I want to replace this mass. So can I write down it as density into volume? Density multiplied by volume. And how do we calculate the volume of any surface? We take the area and multiply it with the thickness. So rho will remain as it is. Volume, I'm replacing volume. So volume will be equal to area multiplied by thickness. Now what is the thickness of water column? Exactly equal to h, the height of water column. So I can write h over here. So mass is equal to rho A h. Can I put this value of mass over here? Pressure is equal to rho A h g divided by A. A will get cancelled by this A. P is equal to h rho g. So this is the value of the pressure exhibited by the liquid column only. And this pressure is also called gauge pressure. Only this much. Gauge pressure is the pressure exerted by the liquid column. Now see, whenever the vessel is open or we are considering the absolute pressure, one atmospheric pressure will also be there. The atmosphere above the surface of the liquid or the container will also exhibit its pressure. So the absolute pressure would not solely be the only gauge pressure. Absolute pressure would be the sum of the atmospheric pressure plus the gauge pressure. So the absolute pressure will not only be the gauge pressure, but also the sum of atmospheric pressure as well as gauge pressure. So the absolute pressure will be equal to P naught, the atmospheric pressure, I will write ATM over here. Atmospheric pressure plus rho g h when you have to calculate the absolute pressure. And if only gauge pressure is asked, the gauge pressure is only the pressure exhibited by the liquid column, that is rho g h. Just note this down, then we'll do questions on this.
Done, ma'am.
Okay, try a numerical based on this only. Just try this question. First two parts are very easy. Just try to find out the answer and let me know. Take 2 minutes. Yes, any answer? What is the absolute pressure coming?
Absolute pressure is 1.013 into 10 to the power 12 Pascal.
1.13
013
into
10 to the power 12 Pascal.
10 to the power 12 Pascal. How much is your gauge pressure coming?
10 raised to 7 Pascal.
10 raised to the power 7 Pascal. See, gauge pressure is correct. But the absolute pressure, see, for the A part, first part, absolute pressure is equal to atmospheric pressure plus rho gh. Yes. So, what is the atmospheric pressure you've taken? You have multiplied these two quantities. You have multiplied atmospheric pressure with gauge pressure. That's how your 10 to the power 12 is coming. See, atmospheric pressure is 1.01 into 10 to the power 5 or 1.03 into 10 to the power 5 plus rho gh. Density of water is 1000 kg. And you have to remember this value for water is density of water. So that is 10 to the power 3. Acceleration due to gravity is 10. And height is also given you 1000 meters. Yes, 1000 meters it's given.
Yes, ma'am.
So that would be 10 to the power 3. So this would be equal to 1.01 into 10 to the power 5 plus 10 to the power 7. This whole quantity is 10 to the power 7. So this would be 1.01 plus 10 to the power 2 multiplied by 10 to the power 5. So this would give you 101.01 into 10 to the power 5 pascals. You've actually multiplied these two quantities. That's how you were getting 10 to the power 12. Fine. And see, the second part asked you gauge pressure. So gauge pressure is this much only, which you were right. That is only 10 to the power 7 pascals. 10 to the power 7 pascals. And this was the gauge pressure. So is the first part clear to you?
Yes, ma'am.
All right. Did you try the third part?
No, ma'am, I was writing the question.
All right. Just take a minute and try this question as well.
Ma'am, force is 400 dyne per centimeter cube.
How much B part answer was 10 to the power 7 pascal. C part is force is coming
400 dyne per centimeter.
dyne. Why have you converted the unit?
Ma'am,
See,
because it's given in centimeter.
what is given in centimeters? So you have to convert that. You have to write your answers in SI unit. All right, you have to give your answers in SI unit unless specified. If the question demands in CGS unit, it would be mentioned over there. See, how did you do it? Tell me the procedure.
Force is equal to pressure into area.
Yes, force is equal to pressure into area. And what was the pressure that you took?
One, ma'am, the one which you gave over there.
Atmospheric pressure. 1.03 to 10 to the power 5. This one.
No, ma'am, I didn't use that one.
Then which pressure?
No, I confused that unit.
See, the pressure would be the pressure exhibited by the liquid on the submarine. So that would be your gauge pressure, which you have already calculated in the second part. So this pressure would be equal to rho GH multiplied by area. The area is 20 centimeter into 20 centimeter. That is its length into breadth is given, which makes it 400 centimeter square. So that this is given in centimeter. Now see, area 400 centimeters square, we converted into meter because we have to write the answers in SI unit. That's why we have taken over here pascals. So this would give you 400 into, now replacing this centimeter, 1 centimeter is 10 to the power minus 2. So here it is 10 centimeters square. So that would make it 10 to the power minus 4 meters square. So this is the area and the pressure is rho GH, which is equal to this much, which you have already calculated. That is 10 to the power 7 pascals. So the force would be simply the product of this pressure multiplied by this area. That would give you 400 into 10 to the power minus 4 multiplied with this pressure 10 to the power 7 pascals. So this would give you 400 into 10 to the power 3 newtons. Understood?
Yes, ma'am.
Where was the mistake? You've taken pressure differently. Yes, Hishma?
Yes, ma'am.
Pressure, there was a confusion in pressure. Fine. Just note this portion also.
Done, ma'am.
Now see, a concept comes with relative density. Relative density is also known as specific gravity. So if question says specific gravity, don't get confused. That is basically relative density. Now see, relative density is actually the ratio of the density of body by the density of water. Relative density is density of the body divided by the density of water taken at 4 degrees Celsius. And this density of water at 4 degrees Celsius is only 10 to the power 3 kg per meter cube, which I've told you in this previous question. This I've told you, you have to remember this. This is 1000 kg per meter cube, or in CGS unit, the density of water is 1 gram per centimeter cube. So this is the only density of water at 4 degrees Celsius. You have to remember that. For example, the relative density of a substance is given to you as 0.8. Now you have to calculate the density of the body. Relative density is given to you and the question is asking you the density of body. Simply you can multiply the relative density with the density of water. That would give you the density of the body. So relative density is 0.8 and density of water is 10 to the power 3. This is equal to the density of body. So density of body will be equal to 800 kg per. Now, can you tell me what is the SI unit of relative density? Yes, this is the formula is given to you on the screen. Can you tell me the SI unit of it? See,
It won't have any
it
unit.
won't have a unit. Exactly, it will be unitless. Because kg per meter cube is the SI unit of density. And kg per meter cube is on the numerator side as well as it is on the denominator side. So that would get cancelled. So it would be a unitless constant. And also I'm writing it again. Remember the density of water, that is 1000 kg per meter cube, or it is 1 gram per centimeter cube. This is in SI unit and this is in CGH. Note this down.
Done, ma'am.
Okay, try a numerical based on this concept only, relative density. See, the question says that a U-tube contains water and spirit separated by mercury. So let's say this is the mercury level. This hole is the mercury. And it has separated two liquids, two fluids. One is water. So let's say water is in this arm, and the height of water is given to you as how much? 10 centimeters. And in the right hand arm, the next fluid is spirit. This is the spirit. And the level or the height of spirit is given to you as 12.5 centimeters. So this is the condition. Now try the question. Yes, did you get the answer for this? Specific gravity. What is the specific gravity? Relative density? Yes, relative density. See, the pressure at this point, let's say PW, pressure exhibited by the water column, and the pressure exhibited by the mercury. See, both are at the same level. So the pressure would be equal. So PW means the pressure exhibited by the water column and the pressure exhibited by the spirit would be equal. Now see, atmosphere will also exhibit pressure. Pressure will be exerted by the atmosphere as well. So see, now by considering the absolute formula for pressure, P naught means for I am solving for this left hand side arm for the water, plus rho means density of water, height of water column, and acceleration due to gravity. Is this much portion clear? What I have written, I've just written the formula for the pressure exerted by the liquid column. And what is the liquid over here? Water. Yes or no?
Yes, ma'am.
Now see, for this right hand side, it would be similar. Pressure exerted by the atmosphere, this P naught, plus rho means the density of the spirit, height of the spirit, and acceleration due to gravity. Now see, P naught will get cancelled by this P naught because both are same. Once you will transport it on the left hand side, it would get cancelled. Now what are we left with? HW by HS is equal to rho S by rho W. And what is the density of spirit divided by density of water? The relative density of the spirit. That's how what we did. Just before we've seen that the density of the body divided by the density of water gives us the relative density. So over here, density of the spirit. And what is the body over here? Spirit is the body. So then density of the spirit divided by the density of water will give us the relative density. So is this right hand side the relative density of the spirit or not?
Yes, ma'am.
Is the relative density of spirit. So basically you have to consider the ratio of height of water to the height of spirit. So that would give you 10 centimeters divided by 12.5 centimeters. That would equal to 0.8. That is the relative density of spirit. Fine. Just note the answer to this and we'll do one more question on this. Noted?
Ma'am, 1 minute. Yes, ma'am.
Try this question. This is the continuation of the previous question only. See, now it is saying that 15 centimeter of water and spirit means both 15 centimeter of water and 15 centimeter of spirit are added in their respective arms. Means 15 centimeter of water has been added in the water arm and 15 centimeter of spirit has been added in the spirit arm. Now, if water has been added, then if this was the level of mercury, it would get pushed up a little, let's say over here. So this is the mercury portion. Now see, the water column is this. This is the water column. Now see, what would be the total length of water column now?
25 centimeters.
25 centimeter, because 15 centimeter has been added and 10 centimeter was already there. And can you tell me the length of spirit column now? See, 15 centimeter has been added, and initially the length of spirit column was 12.5 centimeters. So the total length would be 15 plus 12.5. That is 27.5 centimeters. This is the spirit column. This is the water column. Now see, we have to do similar thing now. Means if let us take this level, the pressure only at these level will be equal. Pressure at these two level will be equal. So pressure, now see, let us take this left hand side arm. Pressure exhibited by the water column would be equal to the pressure exerted by this column. Now this column not only comprises of spirit now, it also comprises of mercury as well. So that would be equal to the pressure exhibited by the spirit as well as the pressure exerted by this mercury column as well. Fine. Now if we write the formula for pressure of water will be equal to height of water, H rho G, density of water, and G. Then we have to write it for spirit. Let us say this is A point, this is B point. So PA is equal to PB. And PB, this pressure in B column, this portion now comprises of spirit and mercury. Now see, density, now pressure for spirit. That would give you H rho G. H is the height of spirit. Rho is the density of spirit. And G is the acceleration due to gravity. Plus pressure of the mercury column. For mercury column, it would be similar to H rho G. Now H would be the height of mercury. Rho means density of mercury. And G is the acceleration due to gravity. Can you see G would get cancelled out from all of these three? Because it is common, it would get divided if you divide all these three by G. Now see, what are you left with? H water. Is the height of water column available to you? 25 centimeter. Yes?
Yes, ma'am.
So height of water, I've written it 25 into 10 to the power minus 2. What is the density of water?
1000 kilogram per meter cube.
Yes, 1000 kilogram per meter cube. What is the height of the spirit column?
27.5 centimeter.
25 centimeter. 25 centimeter, no, it will be 27.5 minus 2. Density of spirit. You have calculated the density of spirit in the previous question only. Yes, 0.8. So that would be 0.8 and we have to convert it now in SI unit. So this would be, we will multiply it by 10 to the power 3. Now plus height of mercury column. That we have to find out what is the difference in level of mercury. Let it be H into Hg. And density of mercury is also written 13.6 into 10 to the power 3. Fine. So from this equation, will you be able to calculate height of mercury column?
Yes, ma'am.
So it would approximately come out to be 0.22 into 10 to the power minus 2 meters. Calculate it after the class. Do calculate it. You just have to subtract this term from this and then divide it by the density of mercury. Is it clear this? Is it clear till here?
Yes, ma'am.
Fine, okay.
Done, ma'am.
Now see, we have another topic known as Pascal's law. See, Pascal's law says that an increase in pressure at one point of an enclosed liquid at rest is transmitted equally to every part of the liquid and to the walls of container, provided the effect of gravity is neglected. And we have written few points for you. Note them also. Pressure in a fluid at rest is same at all points. And then we have Pascal's law of transmission of pressure, which says that a change in an enclosed incompressible fluid is transmitted undiminished to every part of the fluid and walls of container. And the pressure exerted at any point in an enclosed liquid is transmitted equally in all directions. See, what does this mean? What is the Pascal's law of transmission basically? I have taken this vessel. It has 3 vertical pipes protruding from the surface. Now I've filled it with the fluid. Now see, if I exert a force from here, let's say F1, these are 3 vertical pipes inserted in the spherical vessel. If I exert a force on this, then this portion of the liquid will get a force in the upward direction. It will try to push itself out of the vessel because of this force, and same will happen with this force. Yes or no? If you push it from this direction, won't it go out in these 2 directions? Won't it try to escape out from this because of this force? Yes or no?
Yes, ma'am.
Yes. So let's say if the area is this, can you tell me what is the pressure over this end? Let's say this is the first end, this is the second end, and this is the third end. What is the pressure in this first end? P1.
F1 by A.
Yes, exactly. F1 by A. Now see, if I say the area of this second end is 2A. This is not A, this is 2A. It's wider than this first area. And the force is F2. Now, can you tell me what is the pressure 2 over here in the end 2?
F2 by 2A.
F2 by 2A. Yes, exactly. Now, see, Pascal's law of transmission says that a change in an enclosed incompressible fluid, a change in incompressible fluid is transmitted undiminished. Means there is no change in the pressure to every part of the fluid and the walls of vessels. Fine. So it means this pressure that has been exhibited over here or exerted by the fluid over here or exerted by us because of this force. This pressure is transmitted to every part of the fluid and the walls of container undiminished, means unchanged. So this pressure would be equal to this pressure. P2 would be equal to P1. This is your Pascal's law, according to Pascal's law. So now, can I write the value of P1 instead of P2? What would it give me? F1 by A is equal to F2 by 2A. So A would get cancelled. So second force is twice the first force. Yes?
Yes, ma'am.
Yes, second force is twice the first. Now see, let us consider this third end. Let us say the end area is 3a, means 3 times the first end's area. Now we've applied this force F3, means because of this force, this F3 has been exhibited. Now can you tell me what is the third pressure because of the exertion of this force? P3?
F3 by 3a.
F3 by 3. Now again, according to Pascal's law, this change in this fluid, in this part of this fluid, is transmitted undiminished to every part. So if it has been transmitted to the second end, then it would also get transmitted to the third end. So P3 would also be equal to P1. So what would it be? F1 divided by A is equal to F3 divided by 3A. So now area would get cancelled and the third force would be 3 times the first force. So can you see, in order to compensate the force, in order to compensate the pressure, so as to the pressure does not change, the forces are getting doubled. So this is Pascal's law. Understood what is Pascal's law?
Yes, ma'am.
Okay, just note this down.
Done, ma'am.
See, we have a practical application of this Pascal law only. That is the working of hydraulic lift. Hydraulic lift is basically used to lift a heavy load with a small force. So let us see its construction. It consists of two vertical cylinders. Let's say A. Let's name this as B. It consists of these two vertical cylinders of different cross section area. Let the cross section area of this narrow tube be A1 and the wider tube be A2. So is it clear that A2 is greater than A1?
Yes, ma'am.
By looking at the figure only, you can see A2 is greater than A1. Now see, these are connected. These two cylinders, A and B, are connected to each other by a horizontal tube. This horizontal tube, let's name it as C for our convenience. So this is the construction of hydraulic lift. Now, this system is filled with water or oil, that is our fluid. Fine. So this fluid in this hydraulic lift is water or oil used. Now the load to be lifted, and load can be our car, like heavy loads like car. All right. So the load to be lifted is placed on this cylinder with the larger cross section area, A2. Like if this is the cross section area, then the load would be equal. Load would be placed over here. Our load would be placed over here. And the lifting force is applied at the area with the narrower diameter, means the smaller area. The force is applied over here. The F1 force is applied. Now what happens when downward force, this F1 is applied to the smaller piston A, the pressure of the liquid under this piston increases to, can you tell me?
F1 by A1.
F1 by A1. Exactly, F1 by A1. Now, according to Pascal's law, what we have discussed on the basis of what we have discussed right now, this increase in pressure, this increase in pressure is transmitted to every part of the liquid, including the piston B. So you can say that this pressure P, that is F1 by A1, is exerted on the piston B. So therefore, the upward force that would be exerted on this piston B, that would be equal to, let's say P2 is equal to second force divided by area. Yes, P2 is equal to F2 divided by A.
Yes,
What is F2? F2 would be P2 multiplied by A2. And can you tell me what is the value of P2? Will it be same as this P?
yes, ma'am.
According to Pascal's law of transmission, this pressure would be transmitted undiminished to every part of the fluid, and the piston will also receive this pressure. So I can write F2 is equal to F1 divided by A1 multiplied by A2. Yes or no? So this hydraulic lift is basically based on the principle of Pascal's law. Principle of Pascal's law, or you can say it is one of the applications of Pascal's law. Fine. And A1 is the area of cross section with narrow end. And A2 is the area of cross section with wider. Understood?
Yes, ma'am.
Fine, note this down.
Done, ma'am.
Okay, do a numerical based on this concept only. Note the question along with me only. Yes, what is F1 coming?
Ma'am, I still didn't get.
Shall I help you or do you need some more time?
Yes, ma'am, help me.
See, if this is the smaller piston given to you and this is the larger piston given to you. F1 force is applied over here and F2 is applied over here. So a car is lifted, the car is placed on this portion. As I've told you that the load to be lifted is placed on the cylinder of larger cross section area. Now see, the area 1 is the area of the smaller piston would be pi r1 square. Yes or no? The area of the cross section is the area of the circle. An area of the circle is a pi r square. So A1 would be equal to pi r1 square. Yes or no?
Yes, ma'am.
So see, r1 is given to you 5 centimeter. So that would be equal to 20. That would be equal to pi. Then 5 square means 5 into 10 to the power minus 2 whole square. Means the whole square of this radius. That would give you approximately 25 pi into 10 to the power minus 4 meters square. And area 2 similarly. This would be now the radius of the larger area. What is the radius of the larger piston?
15 centimeter.
15 centimeter. So would it be similar to this pi? Just instead of 5, we have 15 centimeters. So this is equal to 225 pi into 10 to the power minus 4 meters square. So we have the area with us. Now, do we have the force with us? If this is the mass, see what is the weight? How do we calculate the weight? If the force exerted is F2 in the above direction, won't the car exert a downward face weight which is equal to mg? Yes or no?
Yes, ma'am.
Weight would be exerted in the downward direction. So now this force means F2 on the larger piston because the weight of the car is 1350 kg. So the force exerted over this would be 1350 into 10, that is 13500 Newton. So we have A1, we have A2, we have F2. Now see, the pressure are equal on both the sides. So pressure over this end would be equal to F1 by A1 and the pressure over this end would be equal to F2 by A2. That's what we have seen. Now these pressure are equal according to Pascal's law because that would be transmitted equally in all the directions. So now F1 by A1 would be equal to F2 by A2. So now you have the value of F2, A2, A1. Will you be able to calculate the F1 value?
Yes, ma'am.
Yes. And once you have the force on the first piston, what is the pressure necessary? Now the pressure is equal to F1 by A1. So if once you will calculate the force F1, will you be able to calculate the pressure using the area A1 and F1? Will these data be sufficient?
Yes, ma'am.
Okay, note these points. And then after the class, try to find out the value of F1 as well as try to find out the value of P1.